Hello everyone, it's Miss Thomas, and today we are going to be looking at sequences. So sequence is a list of numbers that follow a pattern. And this is an example of a sequence, so I'm sure you've seen them before. So the directions here say describe the following sequences and find the next two terms. So we have 2, 6, 18, and 54. And so generally with the sequences, we want to try to figure out how do I get from the first term to the next term. And so you can see if you add, here you're adding 4, here you're adding 12. We're already adding a different number every time, so it's probably not addition. And so we can look at multiplication next since the numbers are increasing. Here we're multiplying by 3. 6 times 18. 6 to 18, we're multiplying by 3 again. And 18 to 54, again, we're multiplying by 3. So the description would be multiply each term by 3 to get the next term. To find the next two terms, we're going to take 54 times 3, which equals 162, and 162 times 3, which gives us 486. Oops. So here is it typed up. Start with 2, multiply each term by 3 to get the new term, and there are two terms. So you guys, this can be the you try. Describe the following sequence and find the next two terms. 2, 4, 7, 11. I hope you can figure out the sequence. So the general term, which is also called the nth term. N is a position number. Okay, so you guys have done this. N usually talks about how many. So when we're talking about sequences, we're talking about what position is it in. The nth term is the actual value in position n, though. So for example, in the sequence 1, 4, 7, 10, 13, if n equals 4 is the nth term, then if n equals 4, then the nth term is 10. So this term is in position number 4, so it is the fourth term, and its value is 10. So our goal is to be able to write equations to model our patterns. The notation, and this notation is all messed up. They should be subscripts, so it should be like U sub n, T sub n, lowercase t sub n, and a sub n. It doesn't really matter what the number is, but the subscript should really be n, and it really means what's in the nth position. So we want to write an equation for the general term of the following sequence. So we have 2 to 5 is a plus 3, 5 to 8 is a plus 3, 8 to 11 is a plus 3. So what we're doing is, to get our nth term, we're taking 2, and every time we're adding 3 to the subsequent thing. So the problem is, if we think about it, I organize myself in a table a little bit better, right? So 1, 2, 3, 4. So when I look at the second position, this is 2 plus 3. When I look at the third position, it's 2 plus 3 for the 5 and plus another 3 for the 8. Fourth position, 2 plus 3 for the 8 plus another 3 to get the 11. So if I were to rewrite this, it'd be 2 plus 3 times 3. And this one would be 2 plus 3 times 2. And this one would be 2 plus 3 times 1. And the 2 could actually be written as 2 plus 3 times 0. So the things that stay the same every time are the 2 and 3. Parts that change are these numbers right here. So that's where the variable should go. And a lot of people would just say, okay, well, it's 2 plus 3 times n, but the problem is this is 1 less than that. 1 is 1 less than 2, 2 is 1 less than 3, and 3 is 1 less than 4. So we really want to take it, times n minus 1, because it's always times 1 less. And so this is our formula. Okay. So this notation did not transfer well here. So it's u sub n equals 4n minus 3. We want to find u sub 4, u sub 17, and u sub 11. I'm sorry, 100. So really all we're doing here is figuring out the fourth term, 17th term, and the 100th term. So for the fourth term, we're going to do 4 times 4 minus 3. So 16 minus 3 is 13. For the 17th term, we're going to take 4 times 17 for the n minus 3. So that's 68 minus 3, so that's 65. So the 17th term is 65. And for the 100th term, 4 times 100 minus 3. So 400 minus 3 equals 397. Okay? So you can see any equation can generate the terms in its sequence. You can see that really all the y values in an equation are a sequence of their own. And the x values are really the position number.